Okay, we're back. I'm back home, and yeah, I want to really want to finish this. Um, yeah, because I'll I'll go traveling again. So really want to finish this, but I have something going on in around an hour. So we'll spend an hour, hopefully finish chapter 17. Um, and maybe come back later today for chapter 18, and then tomorrow we can do 19, 20, and then we're almost done. Rushing to the deadline. Yeah, sorry, because really want to finish this before my schedule before busy again. So we are now doing object-oriented programming feature of Rust. So yeah, I hope that object-oriented programming is not something new to you. So it's a way of modeling program. So it's not about using any programming language. It's just like a way of writing program. I think some programming language are more OOP friendly. Some are not so much so. So it really depends. Object is a programmatic concept introduced in programming language. So it's back in the 60s. Yeah, I'm sure there are books who describe all of this. I don't have time for all the books, all the amazing books. Yeah, what OOP is, and by some of these definitions, Rust is object-oriented programming. Sorry, I'm looking for my lipstick. It's fine. I'll go get it later. Yeah, some people define that Rust is a object-oriented programming. Some define it's not. Yeah, so we'll discuss about it. So yeah, let's just jump into it. There's so much here to read. There's no consensus in programming community about what feature a language must have to be considered object-oriented. Again, like for me, I just think that like it's a way of how to write languages, and some of them more OOP friendly because they have some features, but I think there's no set rules. Rust is influenced by many programming paradigms, including OOP. For example, we explore the feature that, for example, chapter 13, that we would do something like functional language features, iteration closures. Yeah, so some of them are like I think it's very hard to have especially nowadays, have a programming language that's just for object-oriented languages. Yeah, so some will have other features, for example, functional language features that we talk about in chapter 13. That's functional programming languages is that's not those features are not used in the OOP. So object encapsulations and inheritance are the characteristic of OOP. So yeah, to see if Rust support them. Objects contains data and behaviors. So in the book, reusable element of reusable object-oriented software, by a lot of professionals. They're long name. I'm not going to read them. The gang of four books is a catalog of so in a very reputable book, it defines OOP this way: object-oriented programming are made out of objects, an object package, both data and the procedure that operates on the data. The procedure that are typically called methods or operations. Using this definition, Rust is object-oriented. Structs and enum, of course, they are data, but because the struct, we can have an import block that provides the method. So, struct and enum with methods aren't called objects, but they are actually working very similar to that way. So they provide the same functionality. So it kind of fits in that definition. So that's how that's where the OOP kind of come in because of that. Encapsulation is the highest implementation detail. So another aspect, which is the encapsulation, which is like only way to interact with the objects through the public API. Yeah, so you can't really go to like the detail of the object's internal. You're just using a public API, so you can't change the data's behavior like internally. So it's yeah, so it's so that's why like have like keep things in a unit is easier to refactor without changing the code so much. So it's just like imagine that's more organized. How to control encapsulation is chapter 7. We have the pub key, so there's also like some functionality in Rust that is kind of doing that. To decide which module type functions method are public, so that's the public API. So for example, like this, so because it's public, so we can use the average collection. But otherwise, the other things we can't use. Average doesn't have to be computed. So it's max pub, so other code can use it, but the field within is private. So it's important in this case because this is for internal use for the caching of the average. So that's why. So for it to be useful, then we need more public APIs to manipulate it. For example, add, remove, and average. So there are these different functions. Update averages. Yeah, so we can use those public methods to manipulate these internals, but you are not allowed to change anything stored internally. Yeah, so we have encapsulated the implementation. We can change the aspect, for example, data structure. So you can change the internal of it and not having to worry that other code is using it, because the other code can't really like change what's the internal of it. So you know that the other code can only do add, remove, average. So if you change the internal structure, you just need to change all these things correspondingly. Yeah, so because Rust is doing that, so Rust is kind of object orientated in the sense that it encapsulates the aspect of some code. Inheritance is a type system and code sharing. So in object oriented programming, inheritance is also a big thing. It's a mechanism that object can inherit element from the other objects. The parent object's data and behavior that can inherit, you don't have to define them explicitly. If a language must have inheritance to be an object-oriented language, then Rust is not, because Rust doesn't have it. There's no way to define a struct that inherits the parent structure field and method implementation without using a macro. However, if you're used to having inheritance in your program toolbox, you can use other solution, depending on your reason for reaching for inheritance in the first place. You would choose inheritance for two main reasons. One is the reuse of code. You can implement a particular behavior of one type, and inheritance enable you to reuse that implementation for a different type. You can do this in a limited way in Rust code using the default trait method. So this is like, using the trait that kind of lets you to use the default implementation, so you don't have to. So just kind of reusing some code and make your life easier. So you can do that. Yeah, summarize methods. So we use the trait. Yep. Any type implementing the summary trait would have the summarize method available on it without any further code. So this is like a parents class having an implementation of method, and inheriting child class can have its implementation. but we can also overwrite it. Summary method, we can override that with yeah. So the other reason to use inheritance is related to the type system. To enable the child type to be used in the same place as the parent's type, this is called polymorphism, which means that you can substitute multiple objects for each other at runtime if they share certain characteristics. To many people, polymorphism is synonymous with inheritance, but it is actually a more general concept that refers to the code that can work with data of multiple types. For inheritance, those types are generally subclasses. Rust instead use generics to abstract over different possible types and traits bounds to impose constraint on what those types must provide. This is sometimes called bounded parametric polymorphism. Lots of fancy term here. Inheritance has recently fallen out of favor as a programming design solution in many programming languages because it's often risk of sharing more code than necessary. Subclasses shouldn't always share all characteristics of their parent's class, but we do so with inheritance. This can make a program design less flexible. It also introduces the possibility of calling methods on subclasses that don't make sense or that cause errors because the method don't apply to the subclass. Because you inherit everything, so you may inherit something that you don't want and it will be chaotic. In addition, some languages will only allow single inheritance, meaning a subclass can only inherit from one class, further restricting the flexibility. For these reasons, Rust takes different approach of using trait objects instead of inheritance. So, so let's look at, we go back to the trait object again, which is nice. Okay. So in chapter 8, we already mentioned that one limitation of vectors is that they can store elements of only one type. We create a workaround where we define a spreadsheet cell enum that can hold integer, floats, or text. This means that we could store different types of data in each cell and still have the vector representing a row of cell. Perfect good solution when our interchangeable items are fixed set of types that we know when our code is compiled. However, sometimes we want our library to user to be able to extend this set of types that are valid in particular situation. How can we achieve that? So, for example, a GUI tool that iterates through a list of items, calling a draw method on each one of them to draw it to the screen, a common technique for GUI tool. We create a library called GUI that contains the structure of a GUI library. This crate must include some type of people to use, such as button, text field. In addition, GUI user will want to create their own types that can be drawn. For example, one programmer may add an image, the other may add a select box. So we won't implement a fully fledged GUI library for this example, but we'll show how to how the pieces fit together. We can't know and define all the types because people may want something that we didn't think of. So, but we know that GUI need to keep track of many values of different types. Need to call a draw method on each of these. So it doesn't need to know exactly what will happen when we call the draw method. We just the value we have to have the method for us to call. So to do this in a language of inheritance, we may define a class named component that has a method named draw. The other classes, such as button, image, select box, would be inheritance from the component and thus inherit the draw method. They could each override the draw method to define their custom behavior, but the framework could treat all of the type if they were a component instance and just call draw, because everybody should have draw, right? But because Rust doesn't have that inheritance, we need another way to structure the GUI libraries to do that. So to do that, we in Rust we would define a trait named draw that would have the method named draw. Then we would define a vector that takes a trait object that points to both an instance of a type implementing our specific trait, and a table used to look up trace methods on the type of at runtime. we create a trait object by specifying some sort of pointer, such as an reference or a box t smart pointer. Then the d1n keyword, and then we'll specify the relevant trait. Must use a pointer for trait object. Yeah, because the size is kind of unknown. We can use trait object in place of a generic or a concrete type. Whenever we use a trait object, Rust type system will ensure at compile time that any value used in that context will implement the trait object's trait. We don't need to know all the possible type. So again, it's the same thing because we know that it will have draw because it's having the draw trait, right? So it's kind of same thing as like if it's a component that would definitely have draw. We refrain from calling the struct and enum objects to distinguish them from other language objects. In a struct or enum, the data in the struct field and the behavior in the input block are separated, where in other languages, the data and behavior combine into one concept is often labeled as an object. However, trait objects are more like objects in other languages, in the sense that they combine the data and behavior, but trait objects differ from traditional objects in that we can't add data to the trait objects. Trait objects aren't as generally useful as objects in other languages. Their specific purpose is to allow abstraction between common behaviors. So let's look at how it works. So we will have the trait draw, and draw we have a function draw, which is fine. And then, similar to from a discussion on how to define trait in chapter 10, we should have already known it, assumingly. Next, come with some new syntax. So 14.4 will define a struct named screen that holds a vector named component. This vector is of type box. So now we can have a component, so they're public. So we have screen, we have the component in it, and it's a vector of things, and they are the box pointer, and is with the anything that is like anything that has like the trait draw. So this is a trait object standing for any type inside the box that implement the draw trait. Okay, so any type that has a draw trait will fit in this box. So any T that fit in this definition will be the type that we are pointing to. So, right. On the screen struct, we'll define a method named run that we'll call the draw method on each of these components. Okay, so wait a second. Yeah, I will be back. I'm a little bit distracted by something. I will be back. Okay, sorry about that. Okay, so let's read this again. So now we have the screen struct, and then we'll have the input of the screen as well. So when we run, then we would look for the component and then draw them one by one, right? So the component in that vector, which is the vector in self component dot so turn it into an iteration, give me back one of them one by one, and then each one of them, they will have the draw method for sure. Because we have say so. So yeah, so we can confidently call draw because we know that anything that has the draw trait is we have draw. So this is what it is. Works differently from defining a struct that uses a generic type parameter with trait bounds. A generic type parameter can only be substituted with one concrete type at a time, while a trait object allows for multiple concrete types to fill in for the trait objects at runtime. So this is different. So this is screen. So screen will have any type that is that has draw. There's like it has a draw trait, and then I'll put them here. So this is different from what we do here, because this one then, like, it could be any type. This one, it could be any type that have draw, but they have to be the same. So all the components need to be the same thing. But the other one is different. So, yeah, substitute one concrete type at a time. So trait object allows for multiple concrete types to fill in for. Yeah. This restricts the screen instance that has a list of components of all type buttons. So you can only use one type at a time. Only ever need so if you want a homogeneous collection, you can do that. But yeah, with the method using the trait objects, the screen instance can hold active as well as text field. Yeah, so if we do that, then we can have any like different things in the vector. So implementing the traits. So in the draw trait, what we would have more than just the draw function. So for example, like we have button, we also have like these different values for the button, and then we have to implement draw. So that's why we need the function draw the button there. So someone can also implement another thing. So this, for example, this is what we given them, right? But if someone is using it, is trying to draw to create another thing, another component that also have draw. So what they can do is that they can write their own select box, and then, for example, they would pull the trait draw from GUI, and then they can implement it themselves. So this will also work. Yeah. Library user can write the main function that create the screen instance. So screen equals to screen, and then components will be a vector of a box new select box, and then all this thing. This is the select box. This is this one, right? Or it can be a button as well, a button struct and a select box struct and a screen.run. So this will work. You become a trait object. Yep. When we wrote the library, we didn't know that someone may add the select box type, but our screen implementation was able to operate on new type and draw it because select box implement the draw trait, which means that it you have the draw method. This concept of being concerned only with the messages a value responds to rather than the value's concrete type is similar to the concept of duck typing in dynamically typed languages. If it walks like a duck and quacks like a duck, it means that it must be a duck. Yes. In the implementation of run on screen, run doesn't need to know what's the concrete type of each component. It doesn't check whether a component is a certain type. It just calls the draw method, and by specifying box, dy, and draw is the type, then we know that each one of them will have the draw method. So it's fine. So it has the draw method, it's probably fine. yeah, with our define screen to add values to that, so we can call the draw method on. The advantage of using the trait object and Rust type system to write code similar to code using duck typing is that we'll never have to check whether a value implement a particular method at runtime, or worry about getting errors if a value doesn't implement a method, but we call it anyway. Rust won't compile code if the value don't implement the traits. So for example, if you now have a string, right? But the string doesn't have a draw method, so yeah, it doesn't have a draw trait, thus it doesn't have a draw method, so it would just not compile. So it needs to be having a draw trait, which means that it has a draw method, because we have to call the draw on it. So lots of draw. Trait object perform dynamic dispatch. So performance of code using generic session. Oh, this funny word again, monomorphization process performed by the compiler when we use the trait bounds on generics. The compiler generates non-generic implementation of the function and method for each concrete type that we use in place of a generic type parameters. The code that results from monomorphization is doing static dispatch, which is when compiler knows what method you're calling. Is opposed to dynamic dispatch. So before we have this like monomorphization, right? So it just like means that if the function and method calls are static, the compiler will just copy and paste whatever that is. But if it's if we are not sure at compile time, so we have to do dynamic dispatch, which the compiler can tell the compile time which method you're calling. The compiler emit codes that at the runtime will figure out which method to call. So when we use the trait object, Rust must use dynamic dispatch. The compiler doesn't know the type that may be used within the code that used the trait object. So it doesn't know which method implement on which type to call. Instead, at runtime, Rust uses the pointer inside the trait object to know which method to call. So you need to go down the path like what we are thinking. So there's no shortcut here. This lookup incurs a runtime cost that doesn't incur with static dispatch. Dynamic dispatch also prevents the compiler from choosing to inline the method's code, which in turn prevents some optimization. However, we did get some extra flexibility in the code that we write. So the more dynamic it is, the more time it takes, basically. So this thing, if I remember, it just means that filling in the concrete types. So if the compiler can predict or already know, not predict, but funky. If the compiler already know what it is. Hello, Cowder friends. Yes. Rust learning is fun. Actually, I really like Rust. Yeah, it's really cool. I wish to write something useful very soon. Yeah. Okay, so if the compiler knows something in advance that it could copy and paste something there, so to make things faster, then it would do it. But because if we do this trait thing, we don't know the exact type. We don't know what the draw method is in advance because it may be implemented by the user. So the compiler can't really copy and paste and compile it and make it faster. So it will be slightly slower, but it's fine because if we need it, we have to do it that way. Implementing an object-oriented design pattern. We define a set of states. So, stage object. The behavior changes based on this state. We're going to work through an example of a blog post. Ooh. Draft review or published. State objects share functionality. In Rust, of course, we use struct and trait rather than object and inheritance. Each state object is responsible for its own behavior and for governing when it should change into another state. The value that holds the state object knows nothing about the different behavior of the state or when to transition between states. Interesting. That way defines it. So it kind of works differently from a object-oriented programming way. So because each one of them just like so it just being responsible by itself. The advantage of using state pattern is that when our business requirements of the program change, we don't need to change the code of the value holding the stage or the code that uses the value. We only need to update the code inside one of the state object to change its rules or perhaps add one more state object. So what does it mean? First, we're going to implement the state pattern in a more traditional object-oriented way. We use an approach that is a bit more useful, more natural in Rust. So, for example, a blog post starts as an empty draft. When the draft is done, a review of the post is request. When the post is approved, it gets published. Only published blog posts return contents to print, so an approved post can't accidentally be published. So any other changes attempt on a post should have no effect. For example, if we try to approve a draft blog post before we have requested a review, the post should remain unpublished draft. So this is how we would write it. The example usage of API we will implement in a library crate named block. We didn't compile because we haven't implemented the block crate. So, for example, it looked like that. We would have post, add text, and then request review, and approve. So, allow the users to create a new draft blog post with the post new. We want to allow text to be added. If we try to get the post content immediately before approval, we wouldn't get any text because the post is still a draft. We have add the is equal, not equal to, right? Oh no, is equal to. Not, what am I? I'm saying it's exclamation mark things. No. So is equal to in the code. So it should have nothing when you first, because it hasn't been approved, so it should give you nothing, right? If it's under review, it's also give you nothing because it haven't been approved. But if it's approved, then you'll see the same thing. So, right. Use the state and hold value. So yeah, there will be a value of holding like what stage the blog post is in: draft, writing, waiting, or reviewed or published. Changing from one state to another will be managed internally within the post type. This state change is in response to the method called by our library's user post instance, but they don't have to manage the state changes directly. So the user won't see the internal state. So yeah, so basically that's it. All these paragraphs are talking about this, no? So it just means that there's an internal state and it's not accessible from the outside. If you access, then it's probably going from into the draft, and then if it's dot review, then now it's waiting, and if it's approved, then now it's approved. Then maybe if you have get the content after approved, then it's published. Yeah, so the user, because the user can't change it, then there's like less mistake that could happen. Defining post and create a new instance in draft state. Post struct that holds some content. So we'll start with the definition of the struct and associate public new function. So this is how we write them, right? So post will have the state, which is the state. So it's option box, or anything with the state trait. Content with the string. So new we have a post. So state will be some. So there will be a draft state there. Then we have to also implement the trait state and a draft struct here. But we have to implement state for draft because otherwise draft can't be put here. The state trait defines the behavior shared by different post states. State object draft, pending review, and published. They all implement the state trait. For now, the state doesn't have any method, and we start by defining just draft state because this is where we start. So when we create new, it will be in the draft state. Storing the text, suppose content. So add text will be save the content, push string. So this is adding the contents there. So it will be import post and it's public because people can add text. Take a mutable reference to self because we are going to change the content. And then ensuring the contents of a draft post is empty. So if it's new, it's in the draft state, so it should have nothing there. The content is empty. After we have called add text and add some contents to our post, the content method to return an empty string. So content input post, now content will give you an empty for now. So now we want to add more. So if we have request review, then we would have sum s equals to self state dot taken dot tick. So what are we doing here? So request review is added. So now state needs to have a request review. So new pending review. So we'll create a pending reviewed. So return. So request review method will return the pending review. So, but if it's draft, if it's request review, it will create a new pending review and return the new pending review. Interesting. So this post, if you call request review, because post had the state, and then what it does is that so S would be this server state will become s.requestReview. Give us a public method called request to take a multiple reference to self. Internal request review method on the current state of post. Second method consume is current state and return a new state. So if we call request review, we will provide a state, a state. So what it will give back is that so this is what it said. It consume the current state, and it will create a new state. The new state is like calling the state of the request review. So basically, if it is draft, it will create the pending review and return the pending review state. If it's pending review, it will just give back itself. Okay, it's getting more complicated. Set state non-temporarily rather than setting it directly with the code. Get ownership of the state value. The state trade. Everybody needs to have a request review. Self and self mu self is the first parameter of the method. So now we have request review, so it needs to be self. Only valid when you call box holding its type. Syntax take ownership of the box. The consume the old state recursion needs to take the ownership of the state value. The option in the state field. Post come in. Call the take method here to take the sum value out of the state view. So because they sum, so we would take whatever that become the S probably. Have a none. This programming language is Rust. So yeah, you can see it's quite complicated here because it's passing around some ownership thing. Rust isn't less unpopulated. And leave a none in its place. So this one will take the S out and then will be in a none. Self does stay equal to sum. Stop review. Because Rust doesn't let us populate this field in struct. Move the state out of post rather than borrowing it. Set the post state. Then we could like self does stay because it's, yeah, we can't do it like that. We have to use the tick to get ownership of the state value. And ensure post can use the old state value after we transform it into a new state. Our request mirror method on draft return new boxed instead of a new pending review struct. So this crazy thing that this dancing here is just because of the ownership thing. So it will take it, it will become none for temporary, and then it will set it to the new created one, either this one or this one. Yeah. So if let is I forgot. If it's none, then it I forgot what it does. But if it's something that it would just do whatever we're expecting now. Yeah, I forgot where is if let. We have to look it up later. So content method also give an empty string right now. We don't have anything to publish, so it's probably fine. So now we want to get approved method. So same approved method, we'll do similar thing, we'll do the tick, we'll do this dance here, so calling approved. So now we also have to have approved. So approved will do, so if it's draft, approved will return itself. So go back to draft because it's draft. It should, it hasn't go through the pending review, so it will go back to draft if it requests approved. But if it's this pending review, then it will create a published. So if it's published, again, you give back itself if it's request review or approved. So and then at the end is the content. So this time, because if we have approved it, then we want it to have something. So state as referenced unwrapped content self. So post delegate content method finally states. So it depends on the state, so we have to update all the states. No, yeah. So now instead of giving nothing, we would just give it whatever the states say that it is. So I would have to call now. So state will have content. If it is published, then it will return the post of content. Reference to the value inside the option rather than ownership. Call as ref. So default is the empty string, but if it is published, then it will have the contents. But we have only approved, we haven't been published, right? So published, oh, okay, yeah, we have the published struct. So yeah, draft, pending, or published. So if it's published, then it will return the actual content. So that's how it is. It looks very complicated at the moment. Yeah. So when it's outside, it looks very straightforward, right? Like you just use it like that, but inside is like a big jungle inside. So why not an enum? Why is this so complicated? Been wondering why we didn't use an enum with the different possible post state as a variant. Possible solution, try it and compare the end result to see which one you prefer. The advantage of using enum is every place that check the value of the enum, we need to have a match expression. Handle every possible variant. They could get more repetitive than the trait object solution. Yeah. Trade-off of the state pattern. So we have seen how to do it with the state pattern. Object-oriented state pattern to encapsulate the different kind of behavior as a post have in each state. The method on post know nothing about the various behavior. We just call different things depending on the state. The way we organize the code, we have to look in only one place to know the different way to publish a post. If we have to create an alternative implementation, then use the state pattern. Yeah, it's exactly what that box said. We have to use the match and enum. State pattern, the post method, and the place we use post doesn't need match. So you don't even need to know what's inside, what are the states. Because if you don't use this, if you use match, then you have to know the state and try to match them. Implementation using a state pattern is easy to extend, to add more functionality. Add reject method that change the post state from pending review back to draft. Request 2 calls to approve before the state can be changed back to changed to published. Allow user to add text content only when a post is in the draft state. One downside of the state pattern is that because the state implementation implement the transition between states, some states are coupled to each other. If we add another state between pending review and published, such as scheduled, we have to change the code in pending review to transition to schedule instead. Less work if pending review doesn't need to change with additional state, but that would mean to switch to other design pattern. And other downside is that we have duplicated some logic. To eliminate some of the duplication, we may try to make default implementation for request review and approved method on a state trait that returns self. However, this would violate the object safety because the trait doesn't know what concrete self can be exactly. We want to be able to use state as a trait object, so we need this method to be object safe. Another duplication, including the request review and approve method on post. Dedicate the implementation of the same method on the value in the state field of the option, and set the new value of state field to the result. If we have a lot of method on post that allow this pattern, then we consider defining a macro. Yeah, this is quite ugly, in my opinion, because it need to take the value out, call it, and then put it back. So it's kind of a bit silly. Yeah, if we can write macro, that would help. So, encoding state and behavior as a type. Rethink the state pattern to get a different set of trade-offs. Rather than encapsulating the state and transition completely on outside code has no knowledge of them, we can encode the state into different types. For example, now a text this. Have a content method on a draft post returns an empty string. We'll make it so draft post doesn't have the content method at all. If we try to get the dropable content, we just get a compiler error. How to do that? So struct post, struct draft post, content string, new dot content. So post will give out the content. With draft post. Yeah, draft post won't have the content implementation. Both post and draft post struct have a private content field. No longer has a state field because we're moving the Any attempts to get around this construct will result in an implementation error. So we can add text to content as before, but note that draft post does not have a content method. Yeah, new will give a draft post, so draft post will have a content, but it won't have a content method. So how do we get to a published post? It's a lot of work to get to the published post. So again, draft post will have the function request review, then it will give another object that is pending review. The pending review object will have the content also, but then it would now also have, so it only have the approve method. So then you can't add text here, you can only approve it because it doesn't have the add text method. So now it become a pending review post that only have the approve method. So if you approve, then it become post, it has content. you have to change into different objects to go back to post. So because if you create a new post, it will actually become a draft post. It's kind of hidden. Yeah. The returned instance. Because so we're actually muting the post, so we have to make it mute. Post dot okay. Right. But also every time you have to let, because it will create a new thing. Doesn't quite allow the main object-oriented pattern anymore, because you have to know what is going on inside. you have to have knowledge to know that, you have to use let, because now it become another thing. And also you have to let it mute, so it's not that hidden anymore. You're quite obvious that what you're doing. So many different ways of doing it. There are good ways, bad ways, complicated ways, straightforward ways, mind-bending, crazy ways. So learning how to do them is kind of, I think, it's an art. You can't just learn it like with a click or something. So yeah. But we have seen what Rust is capable of implementing object-oriented design pattern. We think the problem to take advantage of Rust feature. So we already learned a feature, then the rest is like how to use them, right? So I think the more code you read, the more idea you get, like how to design a code, which one is better. Maybe if you want it to be totally abstract, then like the user doesn't know, then this is not a good one. So enum will be one way, but like if otherwise you have to do all these things, this dance to make sure that the user just treat it like this, right? Just treat it as one thing. There's a lot of things going on underneath. So, the end. No matter whether or not you think Rust is an object-oriented language, after reading this chapter, you now know that you can use the trait object to get some object-oriented feature in Rust. Dynamic dispatch can give you your code some flexibility in exchange for a little bit of runtime performance. You can use this flexibility to implement object-oriented pattern that can help your code maintainability. Rust also has other features like ownership that object-oriented programming doesn't have. And object-oriented pattern won't always be the best way to take advantage of Rust strength, but it's possible. Available options. Next, we'll look at the pattern, which are another of Rust feature that enable a lot of flexibility. So, we're gonna save that for next time because I am starting to talk too much. I talk so much during the conference, and I want to stay at home and not talk for a few days, but I have to do the streaming, so no option. I will continue the pattern and matching for maybe later today because it's super interesting. And Python is trying to do the same thing now, but I guess Rust would have it more straightforward. I do like what I see. I don't like the complexity of it, but I think once you get used to this, then it's not too much of a problem. Like reading this is a pain, but like once you get the logic, it's fine. But for the user, it's super cool because like you don't have to worry about these things. So this is painful for the maintainer, but good for the user. Always a trade-off. So so we would read chapter 18 later today. See you. Bye.